How's it going, everyone? Welcome. Olier Gonzalez here. So I want to make a quick recap of how do I get here, particularly with Typescript, which is something that I have to do this series of videos to understand what is the problem that this is solving and why is there is a lot of hate, and even in my own experience, why is TypeScript behaving the way it does, because a lot of the time I don't know what it's doing or what's happening, and that leads me to a lot of frustration, unnecessary frustration, because if you know how something works, it's like, why you have that, you don't have any problem in the first place. So that's the intention of this series of videos. I'll make a quick pause here, and here we are. And well, because this is a course taught by Matt Pocock, where he went through this story about TypeScript and how you can use in your applications and what is the reason to use that. I have to do my own research in terms of where this things is coming from, because Matt Pocock, this software engineer that made this course, he previously worked at Versal. Right now he'd say, hey, or in my case I say, hey, I don't know where the thing is come from, so I do need to know what is this and why this emerged. So I'm gonna make a quick recap of each one of those topics, right? And first to understand how do I get here, so what is the problem that TypeScript wants to solve. I have my own experience working with static language like C#, which is the reason why this tool emerged from a bunch of very smart Microsoft engineers that back then they have extensive experience in this static language, aka C#, right? And now they want to find a way to create a language and a process to make the web development, HTML, CSS, and JavaScript more easy to implement, to fix, and to debug, right? So the code name initially was called Script Sharp, and then have evolved over the couple years as Typescript, right? So in these first sections, Matt Pocock went to describe what is the way or the traditional way to creating this kind of applications using the HTML, CSS, and JavaScript. You just write your JavaScript code, and that is run by the browser natively. But now with TypeScript, you have to this additional step in which you have to tell the compiler to generate is the proper JavaScript code that is widely available for browsers, or even you can specify what is the set of JavaScript, or particularly the ECMAScript version of that JavaScript code that is generated. I'll make a quick pause here. I want to escape from the sound for a moment. All right. So here is when it's describing that particular process, as well as the tools that we need in order to develop applications in TypeScript. What are the prerequisites, right? You need an ID, integrated development environment, and also the tool that allows you to transform this TypeScript code into JavaScript, the TypeScript compilers, and also look at how you can use that and what it's doing behind the scene, and some extensions as well. So in understanding how TypeScript fits into the web development, right? So here is when Matplotlib say, hey, this actually enters into a particular phase on the development known as the build step, right? Where here is going to convert a compiler your Typescript files into JavaScript. And you can get very fancy and fine-tuning a lot of the generated code by the Typescript compiler, right? You can say, hey, compiler, anytime that a file changes, I want to generate a new file. Or hey, compiler, anytime that a file changes, I want you to inspect that and give me some errors, right? So I can now fix them. So this is pretty much what this is describing. And also, in order to make this simple in our front-end development, we use tools like Vite, which it offers two main things. A dev environment, where you can, anytime that you make a change on a file, it will reload the browser. And also the the testing environment, where here you can, well, now in one single command integrate is the dev and the test environments. So there is another tool that is also useful, which is, hey, how can I, for example, run Typescript code and validate that that actually is a worker, something that works, you know? Using now is a TSX for that. And also how you can integrate now the compiler in the CI/CD process as a way to do this static analysis. And I do think that's quite not only interesting, but it's part of the job and part of the valuable things that we can get out of this development, especially if you're building large-scale applications. Please allow me to move again because I'm escaping from the sun. Alright, I think I'm safe right now. So, what's next? Well, is this. The essential. So now that I know where this Typescript came from and how does it fit in our entire workplace and the work pipeline, I look at the essentials by saying, hey, how do you set typing for your primitive values, for functions, for parameters, for returning values, for objects, for map, for set, some gotchas with map, some gotchas with Boolean values, typing callback functions, for example, like event, typing JSON parsing, and typing promises. So the eventual completion of a future computation, right? So that's very interesting. And also I look at other types like any and voids, and the controversy of any and voids, and typing literals, right? And then, well, how you can actually leverage the ID so you can now do things like line introspections, where this function is getting called. Oh my god, I think the sun is calling me. Please give me a second. All right. So leveraging the ID with the existing tools that it provides you. So for example, like, hey, how can I look at the type of a statement, whether it's a function call or a property in an object, and what is the value assigned to a variable, and how you can refactor codes, how you can look at the source definitions, change the source definitions, organizing your imports, automating your imports. Use the quick fix menu to help you with some of these suggestions. And some of those are, hey, if I select this code, what do you offer? Hey, whether it is propose and assign to a new variable, or create a new function, or fix this issue, right? Or identify an error. And what is the most common errors that that can happen in Typescript, right? So whether it is runtime errors that is telling you, hey, you shouldn't do this, or errors that are more explicit about the source, or errors that are quite obfuscated where it came from. And how useful is sometimes to restore the server, right? The dev server. Now, on that, right? Finally, looking at the notion of unions and narrowings, which is most of the time when you want to describe an object which represents is a system, and that describe is a piece of business logic, you sometimes want to enhance that, or cherry picking some of them to create a new representation of a business use case, right? So in that case, you say, all right, how can I now extend this typing using the unions, right? And how convenient is using unions, and also is how can I cherry picking or narrowing is the scope to see if that pass all of the it passes certain criteria. So in this union thing, right, there is this notion in Typescript that anytime that you assign something to a variable, or in this assignment, you have is the widest typing and the narrowing typings. So from broad general typings that provide you some set of functionalities to a narrow one, or even the never type. So here is actually describing is how you can do this union type, how useful it is to do that, what is the most common use case, as well as the narrowing, whether it's by checking these primitive values or checking the key on an object. There's some gotchas doing that in map, how you can do that in tuples, in narrowing, also with the unknown value. So when you don't know the shape of this value, because perhaps the backend is developing that feature, but you know that it must have this by actually creating is a series of if statements. How you can actually do that, right? And also in terms of objects, how you can make sure that a particular value in a key actually determines the shape of all the possible values. Or to put it simple, is that how you can handle separate but related type using this discriminator value. And I think that it enters the realms of the discriminating values based on a type literal, when you have, hey, this is the proper value, and now this can be one or another. A good example of this is, hey, if you have now a package that you want to send over, so some of those products might be fragile, so you want to put a sticker on that, or a food delivery sticker, right, as well. So, but in any case, you want to now, based on a value, determine is what is the shape of it, what is you gonna do with it. And this is what the union discriminators allow to do that. So this is not only true for objects, but also for tuples as well. And how you can define is a default values on top of that. So in the previous video, I went through looking at the objects. And now in the object section, it's say, hey, how can I remember an object at the end of the day is just a representation of a piece of your system. Sometimes it's a business logic, right? So how you can sometimes is extend the functionality of that object. So you can now reuse that or extend the functionality, or even cherry picking some of these properties from another already existing class. So in those cases, you can do that is whether it's using a type or an interface. And I look at the difference between the type and an interface. And now the types using the intersections, that what it's doing behind the scenes is mashing all of this key into a new computed type, all merged together. And when you do that using interface, it actually is adding all of these or objects to extend the functionality as well. This is why the docs say, hey, anytime you need to go and define an object, use now an interface rather than a type. And there's some gotchas here. So because types, what it's doing is mashing all of this together in an intersection. So the resulting typing from all of this mashing of key values sometimes can be quite hard to spot on, right? Whereas if you use now interface, you can now spot the problem, especially when you extend from other objects, because it tells you is where the problem is. It's more explicit about it. Now, there's also from performance-wise, the interface are catch, whereas intersections, especially when you combine with when you define types with intersections, Typescript has to recompute all of that. So it makes a ton of sense for sometimes, or if you're developing an API going with interface rather than types, it make much more faster the static analysis. So that makes a lot of sense. And well, how you can now is describe is dynamic key in objects, as well as dynamic key or supporting defaults values in your object as well. So this is what we looked in the previous videos. So let's go now with this one, right? And I'm gonna make a quick pause here. I'm escaping from the sun. So let's get into this.
In this exercise, we have a hasKey function that takes in an object and then also takes in a key. Then it calls object.hasOwnPropertyKey on that object. Cool, simple enough. So it's kind of like an abstraction over hasOwnProperty. It's a little not particularly useful, this function, but it really demonstrates something interesting, which we'll see below. We have a couple of test cases. It should work on string keys. Okay, we have an object with a string key of foo, and then the value is bar. And it should say expect hasKey object foo to be true, and expect hasKey object bar to be false. Great. That's all working. Beautiful stuff. But if we go further down, you'll see it doesn't work on numeric keys. So we're getting a type error when we call hasKey object. This object has 1 as the key, and then basically we're passing in bar as the value here. So we're expecting it to have a key of 1, but argument of type number is not assignable to parameter of type string. We go further down, we're doing something with symbols as well. Symbols are a JavaScript feature that declare a kind of unique symbol here. It returns a new unique symbol value on the symbol. And so we can create a foo symbol, which can be a key you can pass to an object. This is valid JavaScript too. And then we can check if it's a foo symbol or a bar symbol here. And these are symbols down the bottom here. So your job is to work out how we can better type this key, because if you look at the tests, everything's all passing and working fine, but this type annotation of string seems too narrow for what we want. And there's an obvious answer, but there's also a cool answer, and I would like you to try and find the cool answer, which is there is a global type available in TypeScript that lets you represent all of these possibilities. Good luck.
Okay, supporting different types of keys in TypeScript. Oh, supporting, exactly, because whether it's, okay, supporting all different types of keys in objects, because keys in objects, it can be a string, a number, or a symbol. You can do something like this. You can write it down in a literal or in a union type like this, right? I think this must be symbol, right? And it actually will work, right? Or you can use something that has been common in TypeScript, that is looking at the TypeScript handbook, right? And say, hey, you know what? Object types here, right? In property modifiers, optional properties, read-only index signatures. So I look at the index signatures in previous videos. Read-only property, something that I think I'm gonna look at that. Optional properties, exactly. Access property checks. Alright, extensive type or extending types as well. Exactly, I already look at that. The intersection types, exactly, the intersection type, right? It's a try. Okay, that's quite interesting. Oh, okay, and it works with interface. That's quite my bending. I wouldn't mix that, but that's it. Interface extension versus intersection, which is also explaining is early in this series of videos. Interface extensions versus intersection, right? And the generic object types, the read-only, tuples, read-only, and the array type. What about if I look at the utilities or everyday types here, right? The primitive, array, any type annotations on variable, function, object types, optional properties. That's right. Union type, defining union and union, working with union type aliases, interface, difference between type aliases and interface. Okay, that's right. Type assertion, literal types, num and enums. That's interesting. Yeah. Well, type manipulation. All right. Type manipulation. Key of type operators, generic maybe. Key of types is this one, maybe this. The key of operators takes an object types and produces a string or numeric literal union of its key. Okay. And produce a string or numeric literal union of its key. Wait, what? Is this one? Key of type operator? It's an operator that takes an object type and produce a string or numeric literal union of its key. So in other words, I can actually do this by saying, hey, key of, this is the key of operator of object. And it's a no argument of type unique symbol is not assignable to key object. It may be an object like this. Right, if I save this, but it failed here. Key object, key of object. What if I say something like this? Yeah, it failed for all of them. Okay, Jesus, come on, stop. But it's from the type. Do I have object type here? Template literal? No, but this is template literal. Map types. Map type here, and by my map types is key of the object. Of the object, right? Checking types, and it doesn't. Okay, so again, the idea of this is to check if I have in Typescript any built-in operator for this, you know, and where I can look at the docs. So type manipulation, created type from types, generic key type of, index access type, conditional, map types, template types, class, reference, utility types. That's right. Utility types like this. Awaited, partial, require, records, read only, pick, exclude. Oh, unless I say something like this, right? Record might be one of them. Extract null parameters. Okay. Constructor, return type, instant type, this parameter type, omit this parameter, this type, intrinsic string manipulation. I do think it is. Pick, omit, exclude, extract, no null. Cheat sheet. On the types. I can say something like this. Is, hey, the type of but it is the, so the key must be is the key of object, right? Shouldn't this work? Argument of type assign is not assignable to parameter or type never. Okay, so when so what it's doing here is say, hey, okay, so it tries to run that typing and it say, hey, no, that's not, I don't know what is that, parameter never type. Do I have record or parameter? Yeah, because this is utilities. That's interesting. Type manipulation, key of operator. The key of operator takes an object type and produces a string of numeric literal union of its key. And produce a string or numeric literal unions of its key. Exactly. Where now the P is the key of points. So it's going to produce is it's going to produce a string or numeric literal union of its type. Okay. A string or numeric literal union of its type. I do think this is something relevant to the key of, but I don't know how to get that. Yeah, I'm not sure how to get that, or how to indicate to Typescript, hey, this can be this one and this one and this one and this one. So in any case, let's go for the solution here.
So the obvious solution here is to say string or number or symbol.
Exactly.
Okay, beautiful. Everything just works. So we now accept any one of these three things. We hover over has key, we can see we have string or number or symbol. But what if I told you there was a more concise way, a more TypeScript native way of doing this? Well, we can use, if we hover over this, we can see that object.has own property. We command click on it, it takes in a type
but what is
property
this,
key. And property key is a...
Yeah, but what is this? I'm trying to look at that. Where is this? Where is that reference? Utility types is okay. Type compatibility, type inference. Where is this, bro? Cheat sheet, no. Decorators, declaration merging, enums, iterators and generators, GSX, mixing, namespace, validator in a single file, namespace and model, symbols, type compatible, type inference, invariable declaration. Where in the French toast do you get that? So this is okay. So this is not on the docs. Let me see if that's true. Parameter or key. Parameter. No, it's not. It's not here. Property key. If I say property key, frequently creating via key of to iterate through the keys of a type. Well, in any case, the way to find this is by actually
Globally
looking
available
at that.
type available in any version after ES5. So we can use property key inside here. So key now takes property key. Beautiful. Property key is useful in all sorts of little situations like this where you want to model all the possible keys that an object can take. So it's useful for index signatures and really useful for this particular case too.
Mm-hmm. That's interesting.
In this exercise, we have a configurations object here, which is being typed as configurations, which is currently a type which is unknown. We have a string union at the top here called environment, and environment is a union of development, production, or staging literal strings. Now the configurations object down below, this is an object with development, production, and staging as those keys, except we have a TS-expect error here, which is expecting this object down the bottom, not allowed, to, well, be not allowed. It shouldn't be assignable as a key. So your job is to try to work out the right type for configurations here, where we don't want to have to redeclare development, production, and staging here. We actually just want one type here. It's going to be one line of code. This actually, no, it might not be one line of code, but it's going to be basically reliant on environment here, so that if we add another environment, it will automatically propagate down to configurations. So it's an object with environment as the keys. I think I've given you enough information for that. Good luck.
So restricting object keys in type, right? So you want to somehow is represent this, okay? So in other words, you want to describe this and now provide specific literal keys to this notation in object notation. So with that in mind, say, hey, well, our keys must be a key of the environment. That's what my intuitions might resonate, right? You say, hey, this key must be an environment, any of these possible values, and this is now the shape of the API. I think it is exactly. So the API base URL, that must be in a string, and this is a timeout here, that must be a number. There's something interesting here. It highlight here and say, hey, cannot find environment. Do you mean because I misspell this? It's like this. So when I hover this, I say, hey, the index signatures parameter type can not be literal type or genetic. Consider using a map object type instead. So in other words, it say, hey, I cannot assign this like this as it is, right? So that's interesting, because at the end of the day, I do want is to make all the possible values like this, right? It's a computer property name in type literal must refer to an expression whose type literal or a unique symbol. Environment only refers to a type, but it's being used as a value here. Did you mean, so if this is being used as a value, it say, hey, instead of doing this, right, in order to narrow down an object for value, you have to follow is this convention. All right. So what you're telling to Typescript is, hey, this configuration types can be is either a development with this shape, or a production with this shape, or a staging with this shape, which is pretty much what I look at the discriminating values. But instead of values, This is now key. So I am discriminating is the typing or the notation of the shape of this object, not only based on its value, but based on its key in this case, right? And that's something quite common here. Okay, so given this set of parameter, or given this key, given this parameter, hey, this is the options, and so on and so forth. This is mapping possible values to mapping possible keys to its values, right? And everything else. And at the end of the day, most of the time, so if you have a problem in computer science, just throw a hash map first, right? Interesting. Very, 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 very interesting. But again, this is an ocean here, right? So if you somehow needs to have a particular value that determines a shape, this is known as union discrimination. Or if you need that a key determines the value, so this is known as the different key or restricting keys option, restricting object keys in Typescript. Makes sense. But again, the relationship here is with the objects. So do you want to create now possible combinations for these notations based on its value or based on its key? And based on that, you can define the typings here. Makes a lot of sense.
Okay, so we know that the members of this, or the values of this object, are going to be API base URL, which is string, and timeout, which is number. So let's just add those into here, for instance. API base URL, grab that, call that string, and timeout, which is going to be a number. Okay, but now, of course, we need to wrap this in something to make sure that it's going to be kind of reliant on environment as its keys. So we can use the record type for this. And you might think, okay, record string, and then add our kind of object into here. This is pretty good. Except, of course, we're not getting an error on not allowed. This is now an object with those keys as strings there. But what if we just want to restrict it to be the environment that's the key? Well, we can just grab environment and stick it inside that record. Nice. Now, configurations is going to be exactly what we think it is, and this not allowed is not going to be allowed because not allowed does not exist in type configurations. It can only be development, production, and staging. If we add another one here, for instance, like QA, then it's going to require us to pass in QA into here. So not allowed is still erroring, but if I comment this out, then it's going to error up here and saying property QA is missing in here, and I would have to add it to my setup. So this is how basically you get a record of keys where you have a union as keys. That's really, really useful. You can also use this syntax. Now, this syntax is a slightly more advanced,
exactly.
But it's basically
that's the syntax that I actually use. This is index signatures for objects.
Unbundling what record does under the hood, and this is using what's called a mapped type. I'm not sure we're going to cover map types in kind of like great detail in this section, but I wanted to show you the kind of syntax here because it's pretty useful to know. It's kind of like an index signature, but instead of using, you could use, I guess, index environment like this, but actually index signature parameter type cannot be a literal type or a generic type. Consider using a mapped object type instead. What this ends up meaning is you can't use a union of literals inside an index signature. It has to be basically this kind of syntax where we say for each env in environment, we get access to the env in here inside this little closure there. So we can actually say API base URL env if we want to. And now this would have to be development here, and the production one would have to be production, and the staging one would have to be staging. Whereas we're not actually using the env here, but we still need it to map over each member of the environment union. So this one's a little bit more advanced, as you can probably tell, and it's totally equivalent to this record. And this record of environments is a super nice way that you can turn literal unions into object keys. Really nice.
an issue with duplicated interface.
In this exercise, we're going to look at a curious property of interfaces. We have my logger here, which is an object, which is being assigned the type of logger, which is declared as an interface, or in fact as two interfaces above it. And really, we want our log function to only need message string inside here. And yet we're getting an error here saying that this level thing shouldn't be required, except currently it is required. So if we hover over logger.log, it's requiring message string and level number, even though this log inside my logger is not. It only needs message string. Your job here is to try to work out why this bug is occurring and what we can do to fix it. And notice that there are a couple of loggers here with the same name. Interesting. Good luck.
This is also one of the issues when working with interface, is that they actually going to take is the last declaration of the interface, right? For last declaration here. The as expected error level is not needed. For example, if I do this, exactly. Okay. But what it's doing here, the interface, to say, hey, I'm going to aggregate this, right? So it's not overriding, right? It's not overriding. It's just exactly. It's not overriding here. It's not overriding here.
Okay, so what you'll notice if you look at this quite closely is that we have two interfaces with duplicate names. We've got interface logger and interface logger. You would expect that these kind of behave as if they were JavaScript variables, where if we have two loggers with the same name, then these would error here, right? You would get a cannot redeclare block scoped variable logger, and this would fail at runtime, to I'm pretty sure, although I've never tried. And you'd think that's what happens here, but no. When you have declaration merging here, this is what this is called. You have two different declarations with the same name of interfaces, then they merge their declarations. So if I were to, for instance, add like an A string on this one and B string on this one, then currently my logger requires me to pass A and requires me to pass B. Look at that. So these declarations are getting merged. Whereas if I delete the one I don't want, and this is the one I don't want because it's got the excess parameter there, let's pull that off. Now I'm only required to pass B, and my error down the bottom goes away. So my logger.log now only requires a message string instead of needing message string level number. So you might be looking at that and thinking, oh, that looks pretty awful. Why does TypeScript let you even do interface declaration merging? Why has it allowed you to have two with the same name? Well, if you use type, then you don't have this problem.
Yep.
Look at this. If we hover over this and it says duplicate identifier logger, it's going to warn you. It doesn't merge them. It just gives you an error and says duplicate identifier. But interface, it doesn't. Now, this will only happen when they're in the same scope, when they're in the same module scope. So if I declare an interface in a different file, which is in a module scope, then it's not going to interfere with that one. I don't need to worry about this cross-project unless I'm doing that deliberately, which we'll get to later. So it's only when they're in the same scope, really declared in the same file. But this is annoying enough that you might want to use types ahead of interfaces most of the time, especially if you're in long files, for instance. So yeah, like the reason this exists is because you need some mechanism of doing this, which we will get to later in this course, where we talk about kind of like global appending to interfaces like window, for instance. So we have, for instance, window is a global interface, and I can, if I want to, actually, where is it? Interface. Yeah, there's the interface for window. This has a bunch of stuff on it, like documents and events, external, blah, blah, blah. And if I want to globally add things to the window, I need a way of doing it. But it can be pretty annoying as an application dev when you have just these two interfaces knocking about and they accidentally have the same name and you get some unexpected behavior. So this is kind of why I tend to recommend type as kind of like a default way of declaring object types. But then, of course, you also need to think about intersections versus interface extends, and there interface wins. So there's no clear winner still between type versus interface, but this behavior is something that should give you pause about using interface by default.
Wait, what?
Okay, so what you'll do is interface, but this behavior is something that should give you pause about using interface by default.
Yep. Yep. Yeah, you're right. So, well, that'll be all for this video. Take care. Bye-bye.